This is the review for the practice test on Unit 3, acceleration, as well as dimensional analysis and significant figures. Acceleration is a change of speed or direction, or both. So the correct answer here is E, both B and D, but it could be either or. It doesn't have to be both at the same time. What three things do you need in order to calculate acceleration? Acceleration is the final velocity minus the initial velocity divided by the change in time. That's the formula for acceleration. So the three things you need are initial velocity, final velocity, and the time that has elapsed. Answer C. In science, moving at a constant speed and direction is acceleration. That is false. Okay, if you're moving at a constant speed in the same direction, you are not accelerating. Only a change in one of those two things, or both, would represent acceleration. The final velocity in the equation is represented by v sub f for final velocity. The initial velocity is v sub I, so vi for initial and then velocity. And the change in time we represent with the Greek letter delta and a small letter t. So it's a triangle usually with one side thicker than the others and then a lowercase t. In this car, in this image, the car is moving in a circle at a constant speed. Does it have a constant acceleration? Well, this is kind of a tricky one because you might think that it's moving at a constant speed, therefore it's not accelerating because it's not speeding up or slowing down. But you have to remember that acceleration refers to a change in speed or direction, and since the car is going in a circle, it is constantly changing direction because it's never going in a straight line. So therefore it is constantly accelerating. A negative answer in acceleration can be positive or negative because you're subtracting two numbers, and sometimes the number you're subtracting is bigger than the one you're subtracting from, so you get a negative result, which means that the object is getting slower because it means that the final velocity is smaller than the initial velocity. Right? If you're doing Vf minus Vi, if the initial velocity is bigger, then you get a negative answer, which means the final velocity was less than the initial velocity, which means you're slowing down. If you experience positive acceleration in a car, you will feel, well, if you've been in a car that's accelerating, which most of us have, right, speeding up from a stoplight, you feel pressed back into your seat by that force of acceleration. Which of these would represent no change in acceleration? The answer here is sitting on a bench because you're not speeding up, slowing down, or changing direction. You have two pens, one bigger than the other, and they both pass through the photo gate in 0.0023 seconds. Which one has the greater acceleration? And this is kind of a tricky one. The greater speed would be the thicker pen, but that's not what the question is. The question is acceleration. And acceleration requires a change over time. So since we don't have we only have one time to measure, we don't have enough information to tell if either of them are accelerating or if one's accelerating more than the other. Okay, so we have this time two pens again, one thicker than the other. The thinner pen takes longer to pass through while the thicker pen passes through more quickly. So even if, again, the times were the same, the fact that the thicker pen goes through faster would mean that the thicker pen, which is the green pen, has a greater speed. And since it's both thicker and it takes less time to get through the photo gate, that tells you it's going actually twice as fast, or 4 times as fast. What do you need to measure as the distance measure for the timing of the car passing through the photo gate? So this one had two correct answers. You actually need two measurements to determine acceleration. You need two measurements of distance. You need the width of the piece sticking off the side of the car so you know how fast it was going through the photo gate, and you need to know the distance between the two photo gates. So we're using a car and ramp and we're changing the distance between the photo gates. And actually, if you wanted to really look at this, there are really two answers that you could make an argument for here, both of which would be A or B. The A is probably more correct because acceleration doesn't, with gravity, doesn't really change. But if you didn't know that and you were testing a hypothesis that the acceleration changed, this would be one way to do it. So in this one, I would have said either A or B. If you said either A or B, you could make a case for being correct. Again, there won't be double choices like this on the real test. It's just sometimes the practice test is a little more vague. All right, if you have a measurement of 16 kilometers per second, how much would that be in meters per hour? This was a typo that got missed. So in order to figure this out, you have to convert kilometers per second into meters per hour. So the first thing you want to do is convert kilometers to meters, which is, there's 1,000 meters in a kilometer. That's an M. And then you have to also convert the seconds into hours. So I would say 60 seconds is 1 minute, and then 60 minutes is 1 hour. Okay, so you would multiply everything across the top, and since the bottom is all ones, it would be just the answer you get. And actually, when you multiply all those together, you get 57,600,000 meters per hour. So if you had trouble with that one, it's because it should have been not that one. It should have been that one, but it was meters per hour, so it would have been bigger. So there was just a mix-up on that one. If you calculate the speed, where should you record this measurement? Okay. First clue: anytime you see the word calculate, that means it is secondary data. Primary data are things that you measure directly in the lab, so either with a ruler or a balance or a graduated cylinder or a stopwatch. Direct measurements go in the primary data table. Anything that you have to calculate, either speed, acceleration, density, if you take the length, width, and height and calculate the volume, that volume would go in the secondary table because you calculated it. If you directly read the volume off the graduated cylinder, that's primary data. But anytime you have to do math, that data goes in the secondary table. Anytime you can measure it directly, you put it in the primary table, which is going to help answer our next question. If you read the timer, and it says 0.357 seconds, where does that go? Well, if you're just reading it right off the device, then that's primary data. It's direct observation. Okay, so here we go. Your final answer should contain 3 decimal places. So here's the answer you get in the calculator, and you know it needs 3 decimal places. So you have to round off at the third decimal place, which would be 8.865. And since that next number was 3, you would simply round it as 8.865. And in this answer, you get a big long decimal, but you need 4 decimal places. So you're going to round it here at the 4th place. Since it's 5 and then a 3 comes next, you would round it off to 0.6315, which was choice A. And how many decimal places? So you don't even have to calculate this. Your answer is based on the numbers you started with. This has 3 decimal places, 4 decimal places, 5 decimal places. Over here we have 3, this has 5, this one has 2. You always go with the smallest number of decimal places. And out of that group of numbers, 2 was the least precise. 2 decimal places is the least precise answer, and that's where your final calculation has to be rounded to. Okay, and here is the one, it's a similar question, but you actually have to calculate it. And when you do it, so the first thing, again, the key thing here is figuring out how many decimal places to round your answer to. And since we have all 4 decimal places except this one value over here has 3, you're going to need to round the answer to the 3rd decimal place. And when you calculate it, you get a a slightly different value from what's up here, you should have gotten 5.180, and I believe the next digit was a 0, but you're rounding to that third decimal place, so you just leave it as 0, and you have to keep the 0 to keep any decimal places that you're supposed to have. Don't just cut it off because it's a 0. Keep it there to show that you're rounding on purpose to the third decimal place. Okay, calculations, open response questions. Definitely make sure you show your work here, because if you use the right formula and somehow you get it messed up along the way, you get credit for the formula. If you plug the numbers in but somehow calculate incorrectly, you get credit for each step along the way. So put everything down here. Don't just write the answer because that's what you got in your calculator, because if you get it wrong and all I have is your answer, I have no idea why you got it wrong. And maybe it was just that you switched two numbers when you put it in the calculator, but I can't see that if you don't show your work. So here we go. So we're trying to figure out what the velocity is after the acceleration. So the real question is, what is final velocity in this problem? We're given everything out of the acceleration equation except final velocity. So the equation is acceleration equals final velocity minus initial velocity over the change in time. We have the acceleration. It's negative 0.57 meters per second squared, and that equals the final velocity minus the initial velocity, which was 0.430 meters per second, and the elapsed time was 3.0 seconds. So what we end up with when we do this out, we multiply both sides by 3, right, and we end up, and then we subtract 4.30 from both sides, or we add rather 4.30 to both sides, and what we get is 2.59 meters per second is her final velocity. So she slows down for 3 seconds and goes from 4.3 to 2.59. Actually, if we're rounding properly, since the 3.0 seconds only has one decimal place, your final answer should be 2.6 meters per second, round. Okay, and the last problem, okay, we have the car going through the two gates, and we want to know what is the acceleration. So again, we're going back to the acceleration equation. A equals Vf minus Vi over change in time. We're not given the velocities directly, but we're given the time through each gate and the width of the car. So we would do final velocity is 1 centimeter over 0.0073 seconds, because that's what it took to get through the second photo gate. Initial velocity is 1.0 centimeters. That's the width of the tab, and it took 0.0268 seconds to get through the first photo gate up here. So we calculate those answers, and then we plug them into the equation, and the elapsed time between the photo gates is 0.7671. I'm going to round the final and initial velocity numbers just to fit them on here more easily, but when I did the calculation, I didn't round them. So just keep that in mind. If you plug in the numbers I put down here, you'll get something slightly different from the final answer, but I'm rounding them just to fit them on the page here. So you would end up with final velocity of 1.37 minus 0.373 over the time of 0.7671 seconds. Okay, again, these numbers up here are rounded, but I didn't round them in the calculation. So the final answer I got for acceleration was 1.3 meters per second squared, right? And I rounded to that first decimal place because we have numbers measured to the first decimal place, so that's what the final answer has to be. All right, again, if you got slightly different answer than that, it may be because you rounded along the way where I didn't, even though it looks like I did here. I didn't when I did the calculation. If you got a very different answer, you may have switched these numbers around perhaps, even though that would wouldn't give you, it would give you a negative, but it shouldn't give you a different answer. Or maybe you used this number, or you used the 25 centimeters, which really isn't part of this calculation. So that's it. Bring a calculator, and if you have any questions, bring them in so we can get them answered right at the beginning of before you take the test. All right, good luck.